Okay, so girls, last term, we ended the lesson with an exercise where we had to find the exact values of trigonometric ratio like this. Yeah? The exact values that we looked at, Grace, was 30 degrees, 45, and 60 degrees. Yeah? And I've told you why the exact values are those such values, because it comes from a specific triangle. Remember that? No? We looked at this isosceles triangle. Yeah? So from here, we looked at the exact values for each of the trigonometric values. So let's just focus on the 45 degrees from here. So from this triangle, let's just label the lengths as usual. So this is the hypotenuse, opposite, and adjacent. Yep. So from here, what's sine 45?
1 over root 2.
1 over root 2. And you know how I said I have a preference to the exact value that I like to use? That's the same thing as root 2 over 2. Remember? Yeah? No? What's cosine 45? Adjacent of a hypotenuse? 1 over root 2, which is the same thing as root 2 over 2. And tan 45 in this case is opposite of adjacent, 1 over 1, which is equal to 1. Yep. Remember, the quick way to get these exact values is if you type in sine 45 in the calculator and you get 0.7, that's root 2 over 2. If you get 0.86, do you girls, and recurring, do you girls remember what exact value that is?
3 over 2.
Yeah, root 3 over 2. Yeah, everything else is pretty straightforward. Now, so we learned how to find the exact values of these certain angles, but what we're going to do today is how to find exact value when you have an angle like that where it's bigger than 90 degrees. Yeah? So when it's bigger than 90 degrees, we need to have a look at what's called the unit circle, which is what you see over there. Unit circle is basically a circle with the center of the origin, with origin at the center, and the radius is 1 centimeters all around. Okay? So, girls, so what this triangle, by the way, is what we're looking at over there. So that triangle, I just need you girls to know how to read it. That triangle means it's 0.707 up and 0.07 units across. Now that grey line, because the circle radius here is 1, what do you think the length of that is? 1. Okay, so keep that in mind. Okay? So I've written in fractions. So that triangle means the same thing as this. Remember, 0.7 is root 2 over 2, root 2 over 2, and 1. Okay? Can you girls see why this triangle is the same as that triangle? How is it? How is that the same as that? How are these three numbers the same as these three? Yeah? Yeah, if you times everything by root 2 here, you'll get the same triangle as that. So don't be confused. All right, now, girls, what we're going to do is we're going to learn to calculate exact values for 135 as a specific example. So, girls, what I want you to do is pay attention to the three trigonometric values as I move the angle to 135. So right now, the angle inside the triangle is 45. So if I move it to 135, okay, one more, okay. Girls, so the 135 degrees is that there, okay? Now, I want you to look at the triangle that's formed over there. Yeah, it's always from here and then it goes that way when you're looking at unit circle. Yeah, it's different to bearings. You know how bearings we go this way? With unit circle, you calculate the angle this way. All right, so girls, I've drawn up that triangle. This is the triangle that you're looking at. As usual, the radius is 1. That's how high it is, root 2 over 2. But my question is, girls, why is that length, or that triangle length, minus root 2 over 2? Why is it negative, not positive?
Axis.
Yeah, girls, right now we're actually dealing with the axis. Because it's like saying it's 0.707 there, but on this side, they're negative x values. So it's minus 0.707 there. Keep that in mind. Does that make sense so far? So from here, girls, okay, firstly, what's the value of sine 135 according to the values you see there?
0.7.
What's that as a fraction, or exact value?
Root 2 over 2.
Yeah. How about cosine? Minus root 2 over 2. And tan? Sorry? Minus 1?
Yes.
Yeah. So girls, what I'm trying to say is, girls, when you have an angle bigger than 90, when it's in that second quadrant, we call that the second quadrant. So unit circle is actually divided into 4 sections. First quadrant, second quadrant, third quadrant, fourth quadrant. So if it's in that section of the circle, the rule is, girls, you'll always find sine value always positive. The other two are negative. The easy way to remember is if it's in the second quadrant, only sine is positive. Now I'm going to teach you why sine 135 degrees is root 2 over 2. If you actually notice, it's the same values as what we had previously, but the only difference is this has a negative value and here's how. Girls, looking at that triangle you see over there, girls, what's that angle in there? How would I calculate that angle?
180 minus 180.
Yeah, so girls, all of this is 135, all the way up until here's 180 because it's a straight line. So if you do 180, take away 135, and that's 45 degrees, isn't it? What I'm trying to say is, girls, when you're calculating an angle bigger than 90, you're basically just changing the angle back to one of the exact angles that we looked at before. So sine 135 is basically the same thing as sine 45. In this case, what is sine 45? Opposite over hypotenuse, yeah, sine. So that's root 2 over 2 divided by 1, which is root 2 over 2. Yep. How about cosine? Adjacent over hypotenuse, that's minus root 2 over 2 divided by 1, which is 2. And tan is opposite of adjacent, that's that divided by that, minus 1. So girls, that's how you calculate exact values with angles bigger than 90. So as an example, if I want to find the exact value of cosine 150, you know how to get the angle here we did 180 minus the angle? That's the same step you do to here. So you do 180 minus the angle. What's that? What's 180 take away 150? Cosine 30. Now, what's cosine 30 as an exact value? If you don't know, use a calculator. Sorry? Oh, is it? I don't know. Yeah. So that's root 3 over 2. Now, last step before you finalize your answer, you have, is it positive or negative according to the values you see there?
Negative.
Negative. In the second quadrant, only sine is positive, everything else is negative, so you have to put a negative in your final answer, and that's basically how you do it. Okay, all of this was just the reasoning behind why I put plus or minus. Okay, so we're going to now explore the third and the fourth quadrant. So girls, as an example, let's have a look at 225 degrees. So let's move it to 225. All right, so tell me the value. Sine 225, what's it in exact value? What's that? Minus root 2 over 2. What's cosine? Come on, girls.
Minus root 2 over 2.
And tan?
1.
Just 1. So, in the third quadrant, sine is negative. Cosine is negative. Tan is the only one positive. Keep that in mind. Okay? So for example, if I want to find, oh yeah, before I move on, girls, when I'm in that quadrant, how would I find that angle? So if everything up until here is 225 and everything up until there is 180, yeah, if I want to find that left over, I would do 225 minus 180. Does that make sense?
Isn't it 270? That's the other angle.
No.
You did 270 minus the other angle. Oh wait, that's the other angle.
Does that make sense?
It is, bro.
So up until, what I've got up until there is 250.
It works the same.
Oh yeah. Right. That's 220. I just want this bit.
It's not, it's just theta.
I just want that bit. So it's me asking you how much more is it from 180? Yeah? So if I do 225 take away 180, what's that? Yeah, 45. Does that make sense so far? Because this is what you need to calculate the exact value of this. So if you have an angle in the third quadrant, so in other words between 180 and 270, you get that number and you take it away from 180. And if you do that, that's tan 60. And does anyone remember the exact value for tan 60?
Root 3.
Yes, root 3. Because remember, girls, the easiest way to remember it is tan 30 is 1 over root 3. Yeah? So tan 45 is the one on top, and tan 60 is the one at the bottom. Yeah? Now, my answer is root 3, but is it positive or negative looking at the results we had here? Positive. So you can just write root 3 or plus root 3. Yeah? If the question was, say, sine 240, you do the same thing, but you put up negative in your final answer. Does that make sense? All right, let's just look at the fourth quadrant last six just quickly. So I'm going to look at sine 315. So right there. So what do you notice? What's only positive in the fourth quadrant?
Cos.
Yep, so only cos is positive. Okay? Now, in that quadrant, if I wanted to find that angle inside the triangle, how would I find that if everything up until here is 315? How do I find the leftover? 360 take away. Does that make sense? So, in order to find an angle in that quadrant, you get that number, take it away from 360. So, sorry?
45.
Yeah, so that's sine 45. And if I put sine 45 in the calculator, that's root 2 over 2. But do I put a minus in my final answer here?
Yeah.
Yes, because only cos is positive in that quadrant. Yeah? Now, you might be wondering, well, can't I just put sine 315? That gives me the answer straight away. You can, but you need to show me this working out that's important in your exam questions. Okay? Because later on, in the next exercise, you also need to find and go backwards. If they give you that, what's the angle? Okay? You can't just put in the calculator and get the answer straight away. You need to be able to do this working out. Okay? So that's the idea, basically. Okay? So I'll write a summary. So, if it's in the second quadrant, second quad, to get the angle, what do I do? What do I take it away from?
180.
Yeah, so 180 minus some angle. Yeah? And only what's positive?
Sine.
Sine plus sine. Okay? The easy way they like to help you remember what are the positive, everything is positive in this first quadrant, all. That stands for all. All sine, cos, and tan is positive. They write S because early sine is positive, T for third quadrant, and C for the fourth quadrant. The way people like to remember is all stations to central. Yeah? Everything's positive here, early sine is positive there, early tan is positive there, early cos is positive there. That's where the term ASTC that you might have heard comes from. Okay? So, third quadrant, girls, how did I find the angle for the third quadrant, which is in this one?
Angle minus 180.
Yeah, angle minus 180. Now, in a lot of textbooks, they actually write 180 plus theta, which I find confusing. Don't use that. Just do that. Okay? And early tan is positive. Okay? And last one, fourth quadrant, how did I find the angle for this one? Yeah, 360 minus theta, and early cos is positive.
Wait, the third quadrant, can we do in the exam theta plus?
Sorry?
If we want to, can we do the theta plus 180?
Yeah, you can. Yeah, because theta is the answer. Well,
So as long as we find that.
yeah, as long as you find that angle. Yeah. Okay, so that's basically what you have to do. Okay. I wanted to write the steps, but yeah, copy this down and start the exercise. Okay? Any questions?
So can we write the answer on the sheet?
No, because you need to show the working out. Working out takes quite a bit, as you can see. So I'll write the summary. All right, so these are my steps to help you answer the questions.